I'm going to use the formal definition of limit to prove that the limit as the input x approaches 4 of 1/2 x minus 3 is -1. So remember, the limit definition starts with for all epsilon greater than 0. So my first line is always let epsilon be greater than 0. I don't know what it is, but that's how close my output here has to be to 1. So that's going to actually also be my last line of the proof. So I'd like to conclude that my output, 1/2 x minus 3, the distance between that and -1 is less than epsilon. Now, the second piece of the definition is as close as you need the output to be to L, there exists a delta, and so I'm going to choose, I can choose delta equal to, and I'm going to leave that blank, but I'm going to choose a delta, and then what I'm going to do is I'm going to say as long as my input, so as long as x is a distance of less than that delta from 4, so this says the distance between x and 4 is less than delta. It also should be greater than 0. As long as that's true, then I'm going to say that that implies something else here, and I'd like to somehow lead from here to the fact that as long as the input's close enough, the output's close enough. Okay, so first step is to simplify that. So that's 1/2 x minus 3 plus 1 is minus 2. So if I had this line, everyone would believe that line. Now, what could convince someone of that line? Well, notice this 1/2 there in front of the x. I'm trying to get it to look closer to this up here that just has an x. So I'll factor that 1/2 out. So 1/2 times x minus 4 is really the same expression as that. So as long as that's less than epsilon, people would believe this, people would believe that. Now, notice here's where I'm at. Here's where I'd like to be. So what if I pulled that 1/2 over to the other side? How do I do that? I multiply both sides by 2. So I get x minus 4 is less than epsilon, 2 epsilon. So you can sort of see now, following the proof, I'm going to lower that implication arrow a little bit. As long as delta is equal to 2 epsilon, then having x minus 4 be a distance, x and 4 be a distance of less than delta, which is 2 epsilon, implies the piece that I wanted to prove. And this is a complete proof of this limit.